circumstances. But I'll... excuse me, my daughter's had a baby and my wife
That's a good one.
This is the first traditional welcome that's ever been interrupted by a piece of 21st century technology. But it's serious, actually.
All right.
The baby's in Princess Margaret. So.
I'll give you a ring, but I'm just in the middle of work. Sorry,
I'll start off with what the problem is. This is a typical coal-fired power station, 1,000 megawatts, generates 1 million kilowatt hours of electricity per hour. It also, at the same time, as a byproduct of that electricity generation, generates more than 2 million kilowatt hours of heat per hour. It uses 5 million litres of water to reject that waste heat up into the atmosphere. At the same time, from the chimneys comes more than 1,000 tonnes of carbon dioxide emissions per hour, along with nitrous oxide, sulfur dioxide, etc. For people to say that climate change is not happening, it's not credible, can't get their head round the Al Gore charts, whatever, I come out from the front end, the pragmatic end. You cannot say this isn't doing anything to the Earth's environment. This is having a significant effect. In London, 75% of London's emissions comes from centralised power generation. In Sydney, that's 80%. It's such an inefficient process. Laws of physics dictate that for every unit of electricity, you're going to generate roughly 2 units of heat. These are maximum peak efficiencies over the year as a whole. Coal is 36%, nuclear is 38%, and gas is 46% if you just generate power. So most of the energy is thrown away. We then lose further energy across the grid, heating up the wires and transformer chambers. In the UK, the regulator has calculated that as being about $1 billion worth of electricity is lost every year just heating up the wires and transformer chambers. And just to put the water in context, the big desalination plant in Sydney will run one power station's water rejecting the waste heat for 32 days a year. And certainly in the agriculture and farming community are now beginning to wake up to the fact that they're in competition with centralised power generation. And they always prioritise power generation first before farms and agricultural industries. It's also damned expensive. And you've got this to come, I think. The next 5-year determination period, about a year behind New South Wales. Starting from this year, because it came in this year, nearly $18 billion worth is going to be spent over the 5 years to 2013-14, just reinforcing the grid and shifting more electrons from the Hunter Valley into Sydney. And that will increase network charges by 83%. Electricity bills in this current year have gone up 22%. In July, they're going to go up another 18% until we reach that 83% increase. Western Australia is going to be facing the same things, and you're going to get used to that. That has created huge political furore, one of the reasons why the previous government got voted out, but the incoming government doesn't appear to have a solution either. And this is what's coming down the track. It's such an inefficient process, and business as usual just means more of the same. And just to give you a context here, this is your electricity bill. You don't see this on your electricity bill. But 40% of your electricity bill is network charges, just shifting the electrons. And by 2013-14, that's going to go up to 60%. And when you look at these charts, the so-called competitive energy market is 9%. 9% of your electricity bill is at the retail end, and that's the only competition that there is. You cannot change your power station, you can't change your transmission network, you cannot change your distribution network. That's all fixed. Loads of people making money out of it. There's nothing that you can do about it unless you generate your own energy. UTS did a lot of work for us, and one of the things that they established was that even a modest amount of decentralised energy would reduce energy bills by $600 million a year That's an average of $130 a year saving on a householder's bill. And it would reduce, depending on how much you did of this, between 1.4 and 3.8 billion pounds in investment over the next few years, and save emissions by between 2.2 and 8.4 million tonnes per annum by 2020. That's the background, a quick background of Woking and London. Woking's not an island. It's referred to as Island Woking since it's off the coal-fired grid. It's 25 miles south of London, and it generates, distributes and supplies all its own energy within borough boundaries. And I achieved that over a period of 14 years. So by the time I'd left Woking and moved to London, that's what had been achieved. Originally done as a local authority for the first 8 years, but I increased this big scale by bringing in the private sector and establishing public-private joint venture companies. We procured the private sector partner. We established the governance. We found that the public sector investment in this could be significantly geared up. Projects are typically financed by 20% equity and 80% loan finance, and what we've really got is 19% of the 20%, which is 3.8%, and we were able to increase the scale of operations by about 10 times, and that's how we were able to get to that complete independence of the grid. We established that joint venture company with a Danish company. I'll come on a little bit later about Denmark. Denmark has the highest proportion of decentralized energy in the world. 55% of its electricity comes from cogeneration and trigeneration, and 25 to 35% from renewable energy. A typical trigeneration system, combined heat and power, in this instance consuming natural gas, but it can also consume renewable gas, generates electricity, captures the waste heat, puts that in a district heating network, a large-scale thermal store across parallel, stores the surplus thermal energy as the electricity profile is going up and down, and uses that back into the system at times of peak. For a third resilience, backup gas-fired boilers for any operational maintenance. In Woking, I implemented 80 of these, well, 81 to be precise, decentralised energy systems, mixed in with renewable energy and fuel cells. Heat-fired absorption cooling, or thermal cooling, is a technology where we convert hot water to chilled water, and they therefore can provide air conditioning and refrigeration. That has a big impact because, as we found in cities, 60% of electricity consumption is just for air conditioning. And there's also the peak problem that causes huge increases in people's electricity bills. In Woking, I installed a private wire network to get around the regulatory barriers. That had the additional advantage that I could actually operate in island generation mode if the grid ever fell down. And I can remember one occasion we had 4 national grid power cuts in a period of 2 years, several of them due to flooding, which you've had here in Australia. One of them, somebody just drilled for a cable out some distance away from Woking. Each time, the town centre, the villages, the whole borough just ran into island generation mode while everybody else around them was in darkness. Interconnected with the distribution network, you people call that the grid. It's not really the grid. The grid is the 500,000 volt network that comes from the big power stations to the grid supply point. And it's important that you understand the difference between the transmission and distribution network, because the costs are at the transmission end, and laws of physics dictate that electricity will always flow to the nearest load. So if you had a solar PV panel on your roof and you're exporting surplus power, it's going to only go to your next door neighbour. That's the laws of physics that govern that. So more than 80 of these operating in Woking to achieve that independence of the grid. Just an example, whole raft of projects. If you come outside of Woking railway station, you will be confronted with the largest glass outdoor photovoltaic system. So we use solar shading to also generate electricity, as well as keep this area cool that would have otherwise got hot with a canopy. One of the town centre tri-generation systems here, and we put most of the stuff that you can't see. It's inside buildings or on buildings or underneath buildings. But in a number of locations, we actually put, in this one, for example, a large window, just for people to go and have a gawk at it. And we had to extend the pavement there about 3 times to take the school parties, the students, universities, industry, all turning up there. Large-scale photovoltaics everywhere. Using the recycled profits from Thames Way, which is the company I created, we reinvested that in things like fuel cells and photovoltaics, and also used that for providing grants to tackle fuel poverty in the private sector households. Woking has the most energy efficient public sector housing stock in the UK, but we needed to tackle the private sector, particularly elderly people living on their own and people on benefits and so on. So we actually brought their energy bills down. And the photovoltaics, I installed 10% of total UK installed photovoltaics in a borough of 100,000 population in a period of 3 years. And that just shows if you go about this in a smart way, you recycle these profits, you can do all kinds of things. Small scale, these are some of the village scale systems. There's a fuel cell up there. There's a quad generation system. I recovered the water from fuel cells and put that into our drinking water network. And yes, it's infrastructure. The thing that makes this work is the interconnection of buildings with thermal networks. These are big stuff you'd see in a city. This is more out in the rural areas. And these little vans would just be trundling around with something that looked like a large hose pipe, and they were just laid in. And of course, the rural areas have the advantage it's invariably soft dig. And so those smaller scale systems could be put in economically. We even built bridges to get across rivers, and we turned those into footpaths and created additional pedestrian and cycle routes across the borough. And so by 2007, in a period of 14 years, I'd reduced emissions by 80% against 1990 levels, which is the same base year for Kyoto. More than 50% reduction in energy consumption, 44% reduction in water consumption. We'd improved the energy efficiency of the housing stock by 33%, and we'd reduced emissions by 80%. What Woking did was so unique that we were awarded the Queen's Award for Enterprise, which is something that's primarily conserved for the sort of industry. Woking is the only public sector body ever to get a Queen's Award for Enterprise, even today. I didn't go unnoticed by Ken Livingston, and I was headhunted and appointed to set up and run the London Climate Change Agency. And London was a bit different. We needed to get the policy and strategy right. The Mayor has executive powers, so for example, in the London Plan, we revised the London Plan to make it an obligatory requirement to put decentralised energy in recycled water networks, 20% renewable energy, and also automated waste collection systems. They had to do that to get planning consent. They didn't do that, they didn't get planning consent. And we drove that through, and that just, when I hear people talk about your weak planning rules over here, loads of examples of this, not just in London, but other countries as well. Existing homes, we dealt with a Green Homes programme, similar to the project I did in Woking, but at a much bigger scale. I mean, London's a population of 7.5 million. The commercial and public sector identified the 20 largest landlords in London who owned more than 60% of the property. So we went after those. We figured if we could get those on board and connected up, then most of what we're talking about could be done economically. New London Plan, we also, London boroughs that were inclined to grant planning consent at a local level had to be approved the Mayor. And we, in the first year or so, we had a number of those come up, and the Mayor rejected them. So the London boroughs soon learnt that not to pass planning applications that didn't comply with the London Plan, because it just delayed the projects. Transport, you'll be aware of, the congestion charging zone, the low emission zone, the extension of what was the Docklands Light Railway is now being extended quite significantly, particularly into East London, as a light rail network, and developers could not start construction until the line had been built and the station had been built, before the first house could actually be constructed. Aviation, not a lot we can do about the planes in the sky, but we can fix the airports, and I'll come on to a moment what we did at Heathrow. Energy supply was by far the biggest. 75% of London's emission came from centralised energy, so we had no hope of meeting the Mayor's targets without doing something on decentralised energy. And the smallest bit, which is actually quite big because it's London, is the mayoral group showing by doing and reducing and decarbonising its own buildings and operations right across the GLA group. And yes, that did see large-scale wind urban turbines. If you go to London today. You'll see these along the eastern side of London towards the Thames estuary, where the greater majority of the wind. In the Thames estuary itself, 1,000 megawatt London Array offshore wind farm, Greater Gabbard, 500 megawatts being built. And the government has copied what we did in London, and they've now are in the throes of building a 17 gigawatt offshore wind farm system all the way around the UK. Reason for that is that we learnt fairly early on that most wind is out of sea. Wind comes from the seas and the oceans. When it hits land, it loses a lot of its energy. And we found it overcome the intermittency issue, because even on windless days, there was still wind out of sea. And so this is a type of, originally developed by the Danes, a type of renewable energy that is much, much less intermittent than onshore wind. My target was to take 25% of London off the grid by 2025 and 50% by 2050, with the remainder supplied by renewable energy. The key part of that was renewable gases. And I looked at the Greater London area and the home counties and established that if we captured all waste, particularly agriculture and farming waste, we could convert, there was enough resource there to convert into renewable gases if we could actually move that into London to supply something like 2 million homes, which is more than half the population of London. So the new London plan transformed London, which even Boris couldn't unpick when he got elected. So this is all legally constrained. It would need primary legislation to turn it around. We also drafted a climate change duty for the mayor and for all future mayors. And we just got that through Parliament about 1 month before the election. So poor old Boris has actually has a statutory or legal duty to tackle climate change. This is just some of the projects we did on the own property estate. Just to give you some examples, City Hall, can't have the mayor in a building that hasn't been decarbonised. It's probably the most complex photovoltaic system in the world. Every PV tile is a different shape and size. The London Olympics, we captured right up the front. We've got 2 massive tri-generation systems there. One of those is up and running and commissioned as we speak, and the second one will be commissioned by 2012. The CityGen project in the City of London, housed in a heritage-listed building, an old Port of London Authority building, and that supplies tri-generation to the square mile, Guildhall, Barbican, the offices and the hospitals in that area. They just give you some of the idea of the technologies, large-scale thermal storage. There's a cogen unit there. We also did some historical buildings that were even older than Sydney Town Hall. The oldest one was St Christopher's Church, which was designed by Sir Christopher Wren, 1775, and that has a photovoltaic spire. So anybody that says you can't do this on heritage buildings, just go to London, or indeed Sydney, because we've done that there as well now. Some of the developments were really going at it. This is a zero carbon development called Bedshead. So a bit like Woking, but in a small development. And they did everything here. They had a car share scheme, electric vehicles. Some of these units had offices attached to them, so people that work from home, self-employed people, didn't have to travel anywhere at all. So the renewable energy policy, which we were actually challenged, it went to public inquiry. We had been clever enough to get the evidence together before that public inquiry, which we won. And it showed that our original 10% renewable energy policy was being readily achieved within 1 year of me arriving there. I started there in 2004, and that was being readily achieved by 2005. 25% of the developments actually exceeded 10%, and 8% actually exceeded 20%. And it reduced emissions across those developments from renewable energy alone by 26%. Again, Boris has to honour these things, because that's now law. I also established an energy company in London as well, similar to what I did in Woking. And I put this out to competitive tender, and we had 9 major energy and utility companies, including 2 oil companies, international oil companies, bid for that. EDF Energy, the huge French energy company, which interestingly is actually owned by the French government, won that tender, and we had established that with that. This was more for the people yesterday, how it works. This is all the legal and trading agreements and the technical connection as to how you actually take a city like Woking or indeed London off the grid. The House of Lords and the House of Commons Select Scientific Committee visited Woking, and they looked at what I was doing in London. You'll find all this information in Hansard, and interestingly, they likened this to the internet. They said all these island generation systems were the LAN, and the public wires distribution network was the WAN, and that's what the future was. We had, because of what I did in Woking, when we looked at London, very, very much bigger, difficult to get around the regulatory barriers, so we needed to remove the regulatory barriers. I submitted evidence to government. It was picked up by Tony Blair, who basically told the Energy Department to get on and fix it, and within 3 months the regulatory barriers were removed. A new class of energy licence was introduced with the rather sexy name of Supply Licence Modification 2009, but we know it as virtual private wire over public wires. In other words, we could use the local public wires distribution network as if it was a private wire and only pay the distribution company a duos charge and avoid all those costs involved in the national electricity market. The success of that, by 2008, the blue stuff is what's up and running. The green stuff is under construction, and the orange stuff has been consented to 2017. Just looking at outer London, out here is Heathrow Airport. British Airports Authority wanted to demolish Terminals 1 and 2 and replace it with a new East Terminal, got caught by the London plan, had to put tri-generation in, had to put recycled water network in, had to recover their waste and convert that to energy. And now call themselves a green airport. So by 2008, by the time I'd left London to come to Sydney, 205 megawatts had been installed, 63 megawatts is under construction, which has now been completed, and 349 megawatts was consented, some of which has started construction, leaving 583 megawatts to be completed by someone else. And of course, we did a lot on transport, electric vehicles, hydrogen fuel cells. These were exempt from the congestion charge, and supermarkets running off of renewable gases derived from waste. Now, in London, we thought that however clever London was, it would have a significant reduction in emissions on the UK and a bit of a reduction in Europe, but would be diluted outside by world emissions. So we established the C40, so this is the 40 largest cities in the world. In Australia, that's Sydney and Melbourne. Obviously, some of those cities are ahead of more than others. We work as a group to learn from each other. London is obviously up there, New York. New York has the oldest tri-generation system in the world, originally put in by Edison in 1882, and Manhattan still runs off that today. Paris has a significant decentralized energy network, doing a lot of stuff on transport, as is Toronto and Los Angeles. I'll just talk a little bit about, this is Sweden. Sweden, this is Malmö. 97% of its buildings, including remote mountain villas and beachside resorts, are connected to the decentralized energy system. It is 1,100 kilometers in length, and it's, and what they have done, it originally started as natural gas in 1975, but over the years they've gradually moved that to renewable gases, and now 65% of the fuel that supplies the decentralized energy network comes off of renewable fuels and gases. I think Malmö will probably be the first city in the world to be completely 100% renewable energy. Copenhagen, 1.2 million population, a huge extensive network that actually now connects other cities and towns up across the system. And also it's the home, this is Avidor, this supplies about 820 megawatts, and that achieves an efficiency rating of 94%. And that reduces emissions by 665,000 tonnes per annum, and they've achieved so far a 62% reduction in emissions. Originally built in the 1920s, originally based on coal, moved to natural gas, but now they're doing the same thing that Malmö is doing and gradually replacing natural gas with renewable fuels. Now this is Sydney, Sustainable Sydney 2030. Great targets, great aspiration, a great plan, Sustainable Sydney 2030, but actually hadn't done diddly squat a couple of years ago. This was the original waterfall chart. I'll come at the end of the presentation and show you where we are today. And they looked at every possible thing to get to that 70% reduction. And even so, they had a 17% deficit. I completely turned that around. I've pretty much got rid of that deficit. But what you need to look at here is what we call green transformers, which is the co-location of tri-generation, recycled water treatment, and automated waste collection. And in order to deliver this, I needed to establish a blueprint, which we call the Green Infrastructure Plan. And that's made up of the tri-generation master plan, renewable energy, alternative waste treatment, decentralised water, and automated waste collection. So tri-generation on average, instead of losing 2/3 of its primary energy, has an efficiency typically of 85%, 95%. But as I said before, Avidor is 94%. Now, cogeneration, tri-generation is not new in Australia. There are some of them operating in Sydney, and I believe some in Perth as well. But they're what we call boiler in a basement schemes. They just supply that building, and because of your regulatory barriers, they undersize them to prevent reverse power flow going into the grid, because the economics of participating in the national electricity market makes the project uneconomic. And so a typical energy provision would be between 15 and 25%. But in Woking and London, by combining or connecting buildings together, I was getting 5 times that, typically between 125 and 135%, because of the time of day of usage. You're not at home using energy, you're at work, kids are at school, or whatever. Energy moves with people, and you need to connect different parts of the community together to capture that. So that's what we're doing in Sydney. So in order to do that, we needed to look at the city in a completely different way. If I can just take you in there for a minute. We brought in Energy Australia, the electricity distribution network operator, and Gemina, the gas distribution network operator, as part of the project team. And because this needed to be designed in concert with their network, this needed to inform their future investment plans so as we could avoid that investment. And so what we did was we were able to, using data provided from Energy Australia, where the electricity was being consumed, not just in annual consumption, but also intensity, and particularly peak consumption, because something like 75% of the capital cost for reinforce the network is for something like 1.5 hours a day for 6 days a year for peak air conditioning when it gets hot in the city. Absolutely ridiculous. We also did the same thing with Gemina, worked out where all the gas was going. So the tri-generation master plan is based on real numbers. They're not estimates or anything like that. They're actually based on real numbers. And these are the hot spots around the city for heating and hot water services. The clever bit was actually unpicking that to work out, both from electricity and gas, how much of that was thermal energy. We'd already established that 60% of electricity consumption in Sydney was air conditioning. We needed to take that off the network and supply that with thermal energy from the heat to cool process of thermal systems. Similarly with gas, we can displace all those big gas boilers in the city. That then enabled us to look at where energy was being used, where the boundaries were, and we call these low carbon zones. They're actually high carbon zones at the moment, but this is how the city is broken up. And the work that we've done so far, which we published in December, and I think some of you have already had a look at, 340 megawatts in the CBD area. And furthest now, Green Square, a new development, similar to some of the work that Curtin is working on at the moment with Coburg and Stirling and so on. So that's the existing energy supply, and that's what we're going to turn it into. It gives you in a bit more detail about every scrap of energy that would otherwise be thrown away by conventional energy systems is captured and recovered. So when you look at something like 360 megawatts of tri-generation, and you're displacing 60% of electricity consumption in the city through displaced electric air conditioning, and similarly with heat, it's roughly about the size of a 1,000 megawatt power station that's being taken off the grid, because you're getting rid of all those wastes and inefficiency at the same time. We looked at 24 different ways of doing this from around the world. There are loads of examples around the world. The only example we don't have is in Australia. There are big systems in Japan, South Korea, China even now have got some big systems going there. And Singapore has just started out doing a decentralized energy network. We boiled that down to the 9 systems, and of that, the free runners. And what we're trying to do here is balance the economics, because we felt that this could be done without grant aid, and the emissions reduction. So it's a balance between those two things that we're trying to do. And we found the front runner on that, which was a distributed thermal energy network, typically running at 95 to 98 degrees centigrade, and decentralized the thermal chillers in the buildings or groups of buildings using single effect chillers. We've also selected highly electrically efficient gas engines, not turbines. Steam turbines are quite inefficient technologies. And we also modularizing it. So the typical module is 4 megawatts. So if there's a 40 megawatt station, you have 10 4 megawatts. That means you can build that up in steps. And when you've completed that network, you can actually manage it, modulate it throughout the day, throughout the different times of the year, far more flexibly than a thumping great big steam turbine could. We also looked at 3 different take-up rates, still ending up with the same result. This is the work that we've given Gemina to. We've got loads of gas around, as indeed Australia has. We've got loads of natural gas around Sydney, but the size of the pipe network are obviously only serving the existing gas-fired boilers and cooking at the moment. And so looking at 3 different scenarios of the most economic way to phase in the augmentation of the gas network as and when we need it. The first phases of the tri-generation system won't need any augmentation at all, but as we move towards the 360 megawatts, we need to bring that in and scale it up appropriately. And of course, because it would be supplying a huge chunk of natural gas, the return on investment with the gas distributors means that most of it can be financed by the company itself, and we only have to provide top-up for any shortfall. We then looked at the economics. This work was led to the Kinesis Consortium, which included Cogen, which is the largest tri-generation proponent in Australia, and Origin Energy, the largest energy company, and also a major gas producer. And so we had the economics checked out by them, and they looked at it as to what they would need to otherwise invest into conventional power stations. They pretty soon learned that the 45% electrical efficiency was far better than 36% for coal, and pretty much on a par with combined cycle gas turbines. But in addition, 2/3 of the primary energy was now being captured and being put to good use for heating and cooling, and also displacing the electricity consumption, particularly peak, which is such a big problem for the distribution company. We looked at operation and maintenance costs, the supply of gas, and the economics of this project will provide the tri-generation proponent an internal rate of return of between 10 and 20%, significantly higher than you would get with conventional power stations. In terms of cost of carbon abatement, in other words, cost per tonne of reducing a tonne of carbon, energy efficiency, number 1, you would expect that. But of course, you can't achieve these huge reductions just by energy efficiency alone. Decentralised energy is number 2, ahead of large-scale wind, ahead of combined cycle gas turbines. Carbon capture and sequestration is 4 times more expensive than a decentralised energy network. We also looked at NOx emissions, just to address any concerns there. We are reducing NOx emissions at the Hunter Valley by about 5,000 tonnes per annum, but we're replacing that with 220 tonnes of NOx in the CBD. That will comply with the state air quality requirements, which are highly sophisticated catalytic converters to take that out. But the other thing that we should recognise is that it only really represents 0.2%. 88% or 78% of Sydney's emissions, NOx emissions, is transport. And even this will be diluted out of it simply because we're replacing gas-fired boilers and their NOx emissions and other elements of the automated waste green infrastructure plan, in particular the automated waste collection system, will significantly reduce transport NOx emissions as well. So these are big stuff. You're not used to seeing this in Australia at all. This is the first example that will be co-located with other systems. This is a large-scale thermal chillers that converts hot water to chilled water. And some of these things, people don't even know what they are. This looks like a community centre. We've got some weirdo architectural designs around the world. And these are tri-generation systems, and gives architects a lot of ideas to play with in coming up with these designs. But it does mean the key part of what we're talking about is this thermal energy distribution network. Now, that 60% of infrastructure, or the cost of infrastructure, is in the trenching. So that is the time that we have put other more expenses, less economic green infrastructure in at the same time. In particular, a citywide recycled water network and an automated waste collection system. I don't know if any of you, if you've all seen the Tri-Generation Master Plan. We kind of wrote it in layperson's terms, so it's not written for engineers. There is a technical appendix that's written for engineers, but have a look at it because it's written in, a lot of lay people have said it's a really good read. One of the things that we tried to capture here is to present to people emissions, because you can't see it, it's invisible. That's why some people have difficulty understanding climate change. A tonne of carbon dioxide emissions is a sphere of 30 metres in diameter. It's about the same size as a hot air balloon. And so what we did here was to represent the emissions of the city in a quasi-3D way. The higher the peak, the greater the annual consumption. These are not individual buildings, these are groups of buildings. Some of them are individual buildings, but most of it are precincts. And the redder it is the greater intensity, particularly peak electricity for air conditioning. We had to produce this inset because we've got a rogue building in Sydney that's far worse than everybody. I mean, the whole city's bad, but this one really takes the biscuit and it goes off the scale. So we had to do a little inset to actually show you just how big that was. Everyone asked me what building that is, but I can't tell you because we're subject to a confidentiality agreement. The radio stations run campaigns for people to guess what building that is. They're blaming state government mostly, I think. We then looked at federal and state government targets, the 20% renewable energy target, what we're going to do with energy efficiency, the insulation program, all that stuff. And where would we be by 2030 if we just relied on federal and state government compared to growth? And the best case scenario would show a 4% reduction in emissions by 2030, way, way off the 70% that we need. However, you put tri-generation in, any building connecting to the tri-generation system will see their emissions reduced by between 40 and 60%, depending on how inefficient they were to start with. So that's with tri-generation, that's without tri-generation, it's with tri-generation. Moving on to renewable energy, I divided this up into renewable electricity and renewable gases. Why did I do that? I'll come on to that in a minute. The traditional renewable electricity systems, including geothermal, hydro, wind and solar, significant marine resources we've established off the coast of Sydney, or generally New South Wales. I guess the same will apply to Western Australia. On renewable gases, again, people have done this, but if you just recover a resource from some remote farm somewhere and just generate electricity, you're going to get no more than 30%. You're a bit like the coal-fired power station having to throw away 2/3 of your primary energy. So the key thing was to move that gas from where it was being generated into the city. And that's what I did in London at a project out in the Surrey Hills, and that was liquefied using small-scale technologies similar to the LNG process, and then transported that renewable gas into London to supply cogen, tri-generation and transport. This is the renewable electricity map. This is the band of marine generation, so we hadn't had to go too far offshore for that. The blue corridor is onshore wind. The red stuff is geothermal. Quite a significant amount of geothermal energy in New South Wales that no one's currently tapping. And of course, these large things are a solar thermal concentration. Moving on to gas, this actually was a far bigger resource than renewable electricity. And so we had to break this down into 4 chunks. This is agricultural and the forestry residues. And the orange or the redder it is, the greater amount of the resource. And we did this within a 250-kilometre radius of the city. That's all we needed to do. So don't have to build out stuff in the Australian desert and spend a fortune reinforcing the grid. We also looked at existing biofuels that were not being used for energy. And again, hotspots around here on the coast. But by far the biggest resource was horticultural and livestock manure. You drive out in these rural places and you see these signs say stock manure dump. That's just all the farmers have to collect all this stuff, because if they left it on there, it would just pollute the ground and you get runoff into streams and so on, and also the potential of salmonella, listeria and other bugs that would be created. So a huge resource there. And a rag bag of resources, landfill gas, sewage, all that. So in other words, every bit of waste, so nothing has to be grown. There are no energy crops in this. We've ignored and took out of the equation energy crops, because that just competes with the growing of food. And we only looked at waste. And you begin to see the agricultural and rural area has actually the majority of renewable resources. So this is renewable electricity. If we were to capture every resource, including some urban scale wind turbines, we could generate 55% of our electricity need. Remember though, this is the reduced electricity needs, because we've reduced our electricity consumption in the city, or will be, by a significant amount. And 45% within that 250 kilometre radius of the city. With renewable gases, cow, pig manure, the city of Sydney's waste, which is quite big, only 5%. This we established, and the 250 kilometres was just an arbitrary figure that I looked at, and I found that that could supply 95% of the renewable gas that we would need for the city's tri-generation system. So to get 100%, I just need to go out a few kilometres more. If I want to do transport as well, I'll go a few kilometres more. So together, renewable gases is actually more than half of the renewable energy resource that is not being captured at all in Australia at the moment. What technologies we use? We use advanced gasification technologies. This is a plasma arc, but you can also use other two-stage processes, including pyrolysis. This shows you what you can do with 100,000 tonnes in terms of maximising recyclables, but using the stuff you can't recycle and convert it into renewable gases. Far more efficient than anaerobic digestion and those other technologies. This actually reduced waste going to landfill by 98%. You're only left with 2% to dispose of. However, it also recovers the water from waste, which for the rural industry can be used for irrigation. It's what you do with the gas that's the problem. If you just generate electricity locally, it's only 30%. If I pipeline that gas to the nearest natural gas pipeline, we'll get 60%, twice as much. However, if I liquefy it and transport it as an energy-dense liquid and then regasify it and either put it into the natural gas pipeline or directly into systems in the city, I get 80%. That just shows you, just by combining technologies, how you can increase the efficiency of these systems. And this is what I did in London. The first project was just outside of Guildford, a place called Albury. Was a landfill gas site, nowhere near an electricity or gas grid, so they couldn't do anything with it except flare the gas. That gas was captured and liquefied. These are the liquid containers, and a vehicle comes along and picks it up and takes it into London, about 35 miles away. And early wins was transport, because the cost of petrol and diesel in the UK is horrendous, so this was very attractive to anybody with vehicles. We tried all different sizes of vehicles, as well as cogeneration and tri-generation. And one of the big supermarket chains, Sainsbury's, some of you that come from the UK might know of them, they run their distribution lorries off of this stuff. Our city recycled water network, there's lots of examples of what the city's doing, particularly in Sydney Park. But one of the constraints is that if you do it by a building or a development process, you generally end up with surplus water with nowhere to go to. So they then have to undersize the thing to stop that from happening. The purpose of a citywide network is to connect all that up, because there are parts of the city where we have surplus resources, parts of the city that need that resource. It will be a two-pipe system. The third pipe system essentially takes recycled water, use it and dump it down the drain. A loop system will keep that water in the city and will only get evaporation and transmission losses, which is much more easier to top up from recycled water. At the moment, all water is treated to drinking water standards at the Warragamba Dam, piped into the city using huge amounts of energy to pump it, and then we drink 2% of it. If you took cooking into account, 10% top whack. 90% of water consumption in a city is for non-drinking purposes, flushing the toilet, using it on cleaning and irrigation and God knows what. So we're not planning to convert this to drinking water at all. There's no point in converting to drinking water to use it for non-drinking purposes. And we can treat this water from some of the heat from the tri-generation system, which is one of the reasons why we're co-locating recycled water treatment with the Trigen. Now, automated waste is completely new to Australia, originally developed in Stockholm in 1974, and now runs about 80 cities around the world run this system. So instead of having garbage trucks coming around in the early hours of the morning, clanging and banging, you put it in these segregated systems. They can be in apartments, they can be on the street, and essentially we have a single pipe system. It takes the different sorts of waste at different times of the day, so it doesn't need more than one pipe, and that is evacuated under the city at 70 kilometres per hour to the receiving station, which is co-located at the Green Transformer station with Trigen and recycled water. Then all we need is an ordinary lorry to come along and take it away. Where this has been implemented in cities, this has reduced transport, waste collection transport by 90%, emissions by 90%, fuel by 90%. It's a real financial winner for the local authorities that do this, because waste collection, whether you know it or not, is the main money that is collected from your council taxes to pay for council services. Most of that is for waste collection. So it makes a big difference. Now, for the building owner, it frees up floor space that it no longer has to set aside, particularly for apartment buildings, office blocks, retail centres. They don't need them big loading bays. They don't need those roads coming in and out, reversing up and all the rest of it. And also, one of the problems that we have with commercial waste, and I'll give just you one example in Sydney, where Customs House, which we've got 7 private sector tenants there, and each one of them has a different waste collection contractor. So we have 8 vehicle movements a day coming in and out of that building. None of that is necessary with an automated waste collection system. We don't collect our sewage in this way anymore, so why should we collect our solid waste in this way? A key part of what we're doing in Sydney is show by doing. Can't expect people to do right across the LJ what we're not doing ourselves. So since I started in Sydney 2 years ago, we've reduced emissions by 17%. We've got some major projects out to tender at the moment. We're currently out to tender for a further 23% reduction, taking us up to 40% reduction. Our tri-generation tender, which I'll come on to in a moment, we've got a $12 million photovoltaics programme to deliver that 30% for the city's own buildings and operations. We're replacing all our street lighting, 8,500 street lights with LED lighting. I'll come on to that in a moment. And we're also implementing automated waste systems. On the tri-generation tender, rather than doing this bit by bit, I've put all 230 city buildings into that tender. It's an output performance specification. I just simply said we want to achieve 70% reduction in emissions, and we want to generate 70% electricity from this system. 30% is going to come from renewable energy. And so the tenderers had to design systems to actually achieve that. And the one that wins the tender is the one that's delivered against the output performance specification. The city, indeed any municipality, is in an ideal position to make this happen. All examples around the world with decentralised energy have been led by the municipality. They own property all across the local government area. They have planning control. They can just make this happen. They can find space for the tri-generation stations. They own the streets. They can dig up the streets. They can put the infrastructure in. There isn't any other entity, and you need to be clear about this, the utilities can't do it, state government can't do it, federal government can't do it. Only your local council can do this in working with the private sector. I went out on 3 different options. So this is design, build, operate and maintain for all of it. Basically, the council wants to go off the grid, and it wants to do it in 2 years rather than 14 years. So it's a bit of a challenge. And that will be a cost to us. That will be a council-owned project. We'd have to pay for the gas and the operation and maintenance, but we get the benefits of the low carbon electricity and the zero carbon waste heat. A second option was to design, finance, build and operate. So this is owned by the energy services company, and all we've got to do is pay our energy bills. And in order to make that economic, we've asked the tenderers how much one-off capital contribution would be required from the city to make that happen. And we did that with 3 sub-options. One was green energy for the same price as coal energy, 5% less and 10% less. And all 3 of those are significantly cheaper than if we did it ourselves. The third option was to actually establish a public-private joint venture energy services company, similar to what I established in Woking and London, to roll out the 360 megawatts. And these are examples that we have already around the borough, around the city, 18 solar energy projects, but relatively small scale to what we needed. Sydney was the first local government to go carbon neutral, so all of their emissions are offset, predominantly with green power. They spend $2 million, or were spending $2 million a year on green power, plus other funding or other spending on other carbon offsets. I convinced the council to convert that into renewable energy fund to implement renewable energy projects on our own buildings and operations. Didn't seem to make much sense to me in giving someone else the economic value of that. And that's what we've done. And that's one of the first programs off the blocks is the $12 million PV program. For those of you that are familiar with Sydney, there's some iconic sites here. This is the Ian Thorpe Aquatic Centre near Darling Harbour, Redfern Oval. This is outside of Railway Square. Taken over the last year a trial program of about 250 LED lights across the city, in the parks and also at Circular Quay and George Street and so on. And what we found is that the worst performing, we tried a range of manufacturers, all those that are submitted. The worst performing was 11% reduction in electricity, and the best performing was 74% reduction in electricity, with an average of 40% reduction across the manufacturers. Again, you may be familiar with some of these sites if you know Sydney. This is Martin Place. This is near Circular Quay where the buses pull round. Martin Place from another angle, and George Street. So if you go to Sydney, you can literally stand in an LED lighting zone and compare it with the traditional lighting, high pressure sodium, mercury arc and so on. 8,500 lights over 3 years, the whole lot's going to be replaced. And the key, again, it's an output performance specification, so those that reduce the greatest amount of emissions will win, and then we'll look at the cost. I'll finish off with electric vehicles because we are trialling a couple of these. What we found, there are two issues that affect this: bad driver behaviour. People that drive petrol and diesel cars badly would drive electric cars badly as well. And so the charge doesn't last anything like as long as the manufacturers say. But you put a good driver in there, they can drive twice as far. The other thing is where you charge the electricity from. If you just connect to the coal-fired grid, you're producing more emissions at the power station than you're saving. So the work that we've done with that suite of tenders that I got out, or some of those tenders are back now, will actually achieve a 70% reduction for the city's own buildings and operations by, not by 2030, but by 2013, 14, the next couple of years. Some of those contracts are underway already. And of course, comparing this with the waterfall chart, we are now significantly more, particularly on trigen and renewable energy, and also the emission savings from the automated waste scheme, because we've taken a lot of transport off the road. The garbage trucks are the most inefficient form of vehicle on the road. They rarely get out of first gear, stopping and starting and so on. And that will also achieve the 70% reduction by 2030. So by 2030, this is a picture of Sydney that you could see. Offshore wind farms, similar to what we have off of the coast of London in the Thames estuary. Wave energy, these are nodding donkeys. They just sit on the seabed generating electricity. And if we can come above the waves and into the city, massive photovoltaics are right across all the unexposed roofs. There will be some urban wind turbines. There'll be lots of micro turbines. In the suburban areas, there will be a lot of these sort of domestic CHP fuel cell type systems. But the key part of the emissions reduction will be underneath the city. So if I can turn the city upside down for a moment, like looking underneath a printed circuit board, trigeneration, initially fueled by natural gas, and as Peter said, that's a transitional stage. That makes this economic. I can build that. But of course, the thermal network is impervious to the technology or to the fuel that's driving it. And we can gradually replace that natural gas with renewable gases developed primarily from renewable gas market in the rural and country areas. That market doesn't exist at the moment because nobody's got any thermal energy network to supply. So you begin to see we need to get the chicken and egg in the right way round. So this gives us our economic decentralised energy network, which, if I can remind you, would supply 70% of the city's electricity requirements. And that's significantly reduced. Most energy requirements, heating and cooling, will be provided from the waste heat of local electricity generation. I'll leave it at that. Happy to answer any questions.